So example 1, now that I've shown you the patterns, give us several squaring possibilities, things that we need to square, and I'm just going to practice those with you. I'm going to do, here's mine, these are not in your book, q plus 4 squared. Now clearly I can break it apart and FOIL it. Okay, I can do that. But it's easier if you use the pattern, and remember that q is in what's called the A position, and 4 is in what's called the B position. Remember, we're using A and B just as locations. So if the result of squaring this, instead of foiling it, is just this, then let's break it down. If q is A, then result of squaring it is q squared. Plus double the product of A and B. What is the product of A times B? 4q. Double it, what do you get?
18.
And the last position is the result of squaring B. B is 4, so what is that squared?
16.
There's your answer. A squared, twice the product of A and B, B squared. If you don't believe me, FOIL it. And if you FOIL it, you will find that that is the answer. This is just a faster method, knowing how the math works, of coming to this answer without foiling. Okay, so this is an addition binomial. Let's do another addition binomial. Let's do 2x plus 1 squared. Is this a plus b or a minus b? Yep. And the answer will always be a squared plus twice the product of a and b plus b squared when it is a binomial squared. So what's a squared? 4x squared. What is the product of a times b? 2x times 1. Can anyone tell me what 2x times 1 is?
2x.
Let's double it. What do you get?
4x.
And what's the final piece? That's your b piece. Let's square that. 1 squared is? Uh-huh. And that's your answer. I didn't have to foil it. I used the pattern I have memorized in my head, and I came up with my answer. You could foil it if you want to, but the one thing that please, huge caution. The answer is not q squared plus 16. When you're squaring a binomial, the answer is not just the first piece and the last piece squared. Remember how foiling works. Foiling is the first times the first, the outside times the outside, the inside times the inside, and the last times the last. Okay, every single piece gets multiplied by every single piece. This is the most common error all the time, and I'll always write FOIL because of this. Let's do one more addition. 2r plus 3 squared. So this is an a plus b. A squared is a times b, double it, b squared. There's your answer. Okay, so these were all a plus b squared examples. Okay, a plus b squared, which is the same thing as foiling A plus B times A plus B. We're going to do some subtraction ones now. And remember, the result of foiling, or of doing this, is A squared plus double the product of A and B plus B squared. Well, we're going to do subtraction ones now, which is just going to change the middle term. Take, for example, Z minus 9 squared. Instead of being A plus B, we now have A minus B, which means the result is A squared minus double the product of A and B plus B squared, because it's a negative. So let's square our first position. What do you get?
Z squared.
The product of A and B is negative 9Z. Double it. Yes, be very careful about that. And negative 9 squared.
81.
Yep. Notice the first or the last piece is still always positive. The first piece is still always positive. 5x minus 4 squared. Another A minus B. 5x squared is 25x squared. 5x, yep, square it. The product of A and B doubled is how many x? Uh-huh. And the last piece squared?
16.
Good. Remember the pattern. A squared minus 2ab plus b squared when it's a subtraction. The only thing is different is the middle piece. How about xy minus 6 squared? First piece, square it.
X squared and Y squared.
The product of A and B, double it. Negative 12, good. The last piece squared. Yep. Practice, practice, practice is the only way this is going to feel good to you guys. So all of these answers are the result of squaring binomials. Okay? Every single one of them is the result of squaring a binomial. Tomorrow, we're going to take all of these answers, these things that we just squared, and we're going to learn how to recognize them and then factor them backwards to their original factors. Okay? Which is not too hard. That's it in a nutshell, guys.